Does anyone need any help connecting to the Wi-Fi? Okay.
Hello, are we better now? More people with Wi-Fi connection? Yes. There are less hands like the last time. Para sacar la foto de acá también. Puedes aprovechar y moverse. I think there are still some people, but you're better. Who still needs help with the connection, not in general, not with live. We all need help in live. Okay. Good morning. I have no idea why I'm using this one. Now, yeah, hello, good morning. It's everything okay? We are all connected to the Wi-Fi? Yes? That was the hardest part. No, it's not. It was not, no. But, okay, yeah. I hope that was the hardest part, at least for hours. Well, good morning, welcome everyone. Bonjour à tous. My name is Alejandro García. I'm here with Felipe and Jeremias on backstage. If you are here, I believe you know more or less what we're going to do, but if you don't, we have like 5 minutes introduction slides. We will be talking about VMware migration with artificial intelligence. No, that was for you to love. Okay. We will be talking about building Neutron layer 3 plugin. This is going to be a workshop. This is not a lecture, so let's relax a little. Let's hope not many things fail. And we will be trying to guide you through some exercises to, well, we will be building a very basic plugin with no production usage really, but just for you to understand the basics and to learn how could you be using this for your environments. So we will be doing a really short introduction for you to just be on the same page. And we will be describing the lab, how you're going to be accessing, and what are you going to be doing. And then I'm going to just pass the microphone to Felipe, so you just get into it. So, I believe all of you understand already what is Neutron. So no need to read. You know what Neutron is, right? Yes. I don't see your hands up, please. Tell me we all know here what we're going to do. So Neutron is the networking service in OpenStack. So we are here to extend Neutron's functionality. That's why the title of this presentation is like that. We did a similar workshop like 2 years ago with the Modular Layer 2 plugin. Has anyone by chance been there? No? Yeah, it was me, the same face. Older. No. Yes. Well, it's like a spiritual successor of that workshop. It's going to be basically the same thing, but instead of doing a layer 2 plugin, we're doing now a layer 3. It's technically, I think, not a plugin, but a layer 3 provider. So you've already seen these slides. It's like a deja vu for you. So first, just an introduction. Why would we ever need to do this in production, or why would we ever need to just do this not academically? We want basically to extend Neutron because we need to support like a lot of devices, and specifically in our cases, we use what we call the white boxing networking. We have open networking. I don't know if you have heard of Sonic, or well, some other vendors that have, let's say, open source switches. So if you have access to a variety of devices, you want to, by some chance, being able to configure and extend and support those devices within Neutron. So of course, that functionality will not fall into the core of Neutron itself, but rather into a plugin system that you may need to develop or to integrate with. So in our case, we will be saying that at the end of the presentation. We have an SDN, software-defined networking controller, which is able to configure these different devices. So from OpenStack, we are going to trigger that SDN. So we need to, basically what we're going to be doing is we are going to be intercepting OpenStack methods or methods, or we will be using callbacks actually to implement the logic, in this case, of a router. So instead of using the vanilla OpenStack router, we are going to be mocking that router with, for this case, on a virtual machine. In production, obviously, you will be doing that in a physical device. For example, we do routing on the border leaves of a data center fabric. So you will be using that. All of that, hopefully, it's going to become more clear when Felipe explains that to you. To be very brief, what we're going to be doing is we're going to be coding a Python class, which will be then inserted into the Neutron server code. And that Python class is going to be registered, and it's going to be invoked every time you do some OpenStack primitives. In our case, the primitives of a router. Okay. So for the lab, what we have done is we have deployed several small OpenStack environments. We expose them via a remote desktop, which is CASP. I don't know if you know it, but it doesn't matter. It's just a remote desktop. And you're going to be accessing that remote desktop using your browsers. And from that remote desktop, you will be opening a browser or a terminal, and you will be able to control the OpenStack environment from that. So you're basically going to do two jumps. Our environments are publicly exposed, but we had a problem with the Wi-Fi network yesterday because they are exposed on ports that are not standard, and the network was also blocking. So we have already another problem with the networking yesterday, but of course we all here know how to do an SSH tunnel, so that's not a problem for us. So you will be doing an SSH tunnel to access the remote desktop, and from there you will be able to use OpenStack commands and to interact with the, well, I'm going to say it right now, but we are using Ansible for our deployment. Do you know Ansible? Yes. Okay, so the OpenStack is deployed on containers. So there will be a container called Neutron server with the Neutron code, and you're going to just exec into that container and be able to modify the code on lib. Fortunately, this is Python, so you just have to edit the code, restart the container, and you will be able to change the code on the fly. So that will be more or less it. You will be modifying the code lib and restarting the container, and you will be able to implement the plugin that way. So here the fun begins. We have a spreadsheet with credentials, yes, because there are like 35, 36, I don't know, environments. Please, you can either open that link, well, you cannot open that link because you don't have it. You can copy paste it. You can use the QR to get access to the spreadsheet. And there you will be finding this different credentials for Horizon, for the servers, and etc. And briefly, Felipe is going to be guiding you with what you have to do. Please register your name or your email right on the right, at the very end of the spreadsheet, so we know who is using which environment. Yes, so you don't have two people using the same environment. Yes. And at the very bottom of this file is the link for this presentation. So you can just follow along because we will be going to copy code. So it will be pretty easy if you just follow the slides and copy paste the code from the slides. Okay? Everyone, yes? They're focused.
You use the same queries, but does that SSH
No, it's okay, but we're going to explain that in a little. It's at the very bottom, but we're going to explain that in a little. At the very bottom of the file are the is the link for the slides. So that will be very helpful because you will be able to copy the commands directly from the slides. And it's the SSH password, but that is going Felipe is going to explain that right now. But you could all open this file, right? Yes. Okay. It's all on you, Felipe.
So let's the fun begin. I'm going to guide you through this workshop. It's going to consist of 4 activities. Basically, I'm going to explain what we're doing while you are following along. As Alejandro says, if you have this presentation on your computer, you'll be able to copy and paste the code that we are going to be changing in the Neutron server container. So it's important for you to have the presentation open. So if you open the spreadsheet, you should see something like this. The access from from left to right is the access that you are going to use. First, you have to, from your computer, do an SSH tunnel, as we say, to the remote desktop on Chasm. From this, you will be following along. So I'm going to do the same as you on my computer, so you can follow what I'm doing. You should open a terminal, in this case, and copy and paste the SSH tunnel command. The SSH is going to be asking you for a password. The password is listed at the very bottom of the spreadsheet. You copy and paste the password, and you should be able to access and open an SSH tunnel that should be open during all these activities that we are going to do. So you should leave this terminal with the SSH tunnel running while you're accessing your environment to do these activities. From this, what you have to do is to open your browser of choice. We recommend you to use Chrome, because we've been experiencing some problems in Firefox with the Chasm remote desktop. So use Chrome, just to be sure that it's working. If you should be able to access the remote desktop. You're going to be seeing something like this once you're inside. Well, if at any point you have any doubt, you can ask me or Fernando in Jeremias, and we will help you. So at this point, anyone needs help? Everyone? You don't get connected? Ah. Just it don't print any command. The
password for the remote desktop is color G. People are using Horizon 5.
Ah, okay. So, tiene un problema.
That's okay because it's there's no because it's a tunnel. Just have a minus L flag. It only opens the tunnel. That's okay.
For you to be able to access the custom desktop, you should use HTTPS. If I can open the SSH tunnel on my computer. So who else cannot access the remote desktop? And everyone can see something like this on your computer? Please raise your hand if you're seeing something like this. So from the remote desktop, you should access the CLI of your controller node. In this case, we are deploying the OpenStack environment on all-in-one. So your controller node is going to be also your compute node. From your remote desktop, you should open a browser. And if you access the URL listed under Horizon in this column, Horizon access from custom, on the column H, you should see the IP import that is exposing the Horizon, the Horizon and the OpenStack. So if you access this URL, you should be prompted from the user and password for access Horizon. You should be using the admin user. That's the same for all the environments. And the password that is listed under the J column. If everything's working correctly, you should be able to open the Horizon console. You also need to access the CLI to use OpenStack commands. For doing that, what you have to do is to, first of all, open a terminal on your remote desktop. It should be something like this. And from this, you have to SSH to the controller node, in this case, also the compute node of the OpenStack deployment. For doing that, you're going to use the access under the LM and N column. In this case, we're going to SSH to this IP, user the Ubuntu user. So you go to your terminal, type SSH, Ubuntu, and the IP. In this case, my IP is 192.168.0.10. And from that, it's going to be prompted the password, and the password for everyone is whitestack. If everything is working correctly, you should be logged into the controller node of the OpenStack deployment. From here, you have to, for execute OpenStack commands, you have to use the credentials files. You have to source the credentials file that is under the etc ycloud admin.openrc.sh file. You source that file, and you have the credentials set in your console. So you can do commands for, like, for example, like OpenStack router list, and you should be you should be able to list your objects in your environment. Okay. Okay. Who is already connected to the chasm and to the OpenStack CLI? Okay, perfect. Okay. It's under ADTC slash ystack slash admin dot dash openrc dot sh. So we're going to wait like 5 minutes so everyone is on the same page, and you should be able to access the CLI and the Horizon console. From that point, I'm going to continue with the activities. It's important that you have the access to both of these methods of access the OpenStack environment. Who needs help? It's not running L3 at this point. It is a router, but it's not based on the plugin that we're going to build. It's a plain OpenStack router. Yes. Okay. So I'm going to exit my CLI. When you have to open a terminal on your computer and SSH to the controller node. The IP is listed on the L column of your spreadsheet. In my case, it's the you have to SSH to with the user Ubuntu, and my IP is the 192.168.0.10. And the password, the same for everyone, it's ystack. For getting access to use the OpenStack command, you should source the credentials files that is listed under ATC white cloud and admin-openrc.sh file. You have to use the HTTPS URL. Who else need helps? Everyone is ready? Yes. Yes. In the meanwhile, you could open the browser and log with your Horizon credentials that are under the I and J column. The user is admin for everyone. You should copy and paste the password. To get to the control node, you have to open a terminal on your remote desktop and SSH to the control server. The IP is listed under the L column on the spreadsheet. So now I'm going to log into Horizon. It's going to ask for your credentials. In this case, it's users admin for everyone, and you paste the password. Okay. Yes, it's oh, it's not letting me copy it. Maybe someone is using the same environment.
Some people have a firewall for people that use your working. So they have like a firewall VPN or something, so it's blocking
Mm.
random ports. And it's blocking you the SSH or the port 24. Can you do it? You couldn't use it. SSH tunnel. Should be blocking either the IP of our server or port. I don't know if you can do it.
Okay. Sorry, who's using the pod 1 on the Open Infra 5 node? Who's using the pod 1 on the Open Infra 5 server? That is already taken by me, so who's that?
If you're using it, they are not using it because they can open the browser, right?
No, se lo
So
van
they
a...
will be able to control it.
Sí.
Yeah.
Sí. Well.
You have it, okay. Yes. That's from Horizon. Console for Horizon. You go to the instances console. The link is but it is broken because it is pointing to the public IP, and the public IP is not working. So you have to just change the IP and the port for the private IP. That's going to be happening later.
Okay, so we are going to continue with this, start with the activities. So what you should do is open a terminal on your controller node. In this case, my IP is 192.168.0.50. You type yes, and the password is YStack for everyone. You also should be opening a browser to access the Horizon console. You're going to use the credentials from here. It's not letting me paste the password. No.
Está dando problemas con Mac.
Está dando problema con Mac. Okay. Okay. So in the first activity, we're going to be doing inspection of our L3 plugin. In this case, we're going to see how we can configure a L3 plugin to tell Neutron to do these callbacks so we can extend the Neutron functionality. In this case, we're using the service provider function that Neutron already is enabled. In this case, we have to configure the neutron.conf file. In this case, we're using a custom file for our deployment. In this case, we have to create the section service provider with the service provider variable. In this case, what we're telling Neutron is to use the L3 router NAT, in this case, that is the router object of Neutron, to invoke a Python class. In this case, the Python class that we're going to be invoking is this listed at the end of this string. And the name that we're going to give this plugin is Paris L3 router. This name was the name that we are going to be using when we create the network service provider, that is the object that enables Neutron routers to extend the functionality from the plugin. So in this case, this file is already present on the Neutron server container. What we're going to be doing is inspecting the file so you can check the current configuration of Neutron. For doing that, you have to open a terminal on your environment. You have to do an SSH to the control node of the deployment. And from here, you could list the containers that are running. In this case, we're seeing that, for example, there are Neutron containers, OpenSwitch containers, Nova containers, all these OpenStack services. The container that we're going to be using is the Neutron server container. To open a bash session on the container, we're going to be using the docker exec command. Okay. So every command that we're going to be using is listed on this presentation. For example, you can copy and paste this command right here, so you can get access to the Neutron server container console. You copy the command and paste it in your remote desktop terminal. I'm going to type it: docker exec -it -user root Neutron server bash. So you should be logged in as a root user inside the Neutron server container. To inspect the file, you copy and paste the path of this file and execute a cat command on this file. As you can see, the file already have the configuration to enable this Python class that we are going to be modifying, because it's already present on the container, as we're going to be seeing later. This configuration is ready, so we can now, for example, create a router using this plugin by creating a flavor, as we're going to be seeing later. But what we're going to do is we're being modifying this class so we can implement the real logic of this router that we are going to be mocking in our plugin. So now that we check that the configuration exists, we're going to the next step. In this case, we're going to be inspecting the Python class that is already created on the container, so we can see what methods are present and what methods we're going to be modifying to implement the logic that we want. To inspect the file, you can copy the path of this file. This file is located inside the Neutron container. So you can do, for example, a beam on this file. And you should be seeing something. Sorry, get copy another path. So you should be seeing something like this. This is our Python class that we already have implemented in your Neutron server. In this case, the Python class is called Paris L3 router. As you can see, we are using some decorators. These are required to tell Neutron that this class is enabling callbacks for the router creation, router deletion of modifying a router. So as you can see, the class have a constructor where we're getting some configuration, some sessions that we're going to be using in the methods that are already implemented, some logs. We have some helper methods for you to use in the callback methods that we are going to be creating later. For example, as Alejandro says before, we're going to be implementing a router via a virtual machine, a BIOS virtual machine. So we need, for example, commands for creating this virtual machine inside the plugin. For doing that, we have the, for example, get Nova client command that returns a Nova session, so we can use the API of Nova to create an instance. We have the list instances command, other commands that are connecting to the Neutron API, for example, to find network ID, create Nova instance. For creating this router VM, these methods are already present for you to use in the other methods that we're going to be using as a callbacks. The callback methods are, you can identify it by the decorators that are present in those methods. For example, if you want to use a method as a callback, we have to register this method as a callback using the registry.receives decorator. In this case, we're telling Neutron that this callback is going to respond to a router creation. It's going to execute this method before Neutron creates its router object on the database. So in this method, we're going to be implementing the logic to create a BIOS router, a BIOS virtual machine, that is going to be mocking the original router object of Neutron. As you can see, at this point, we only have logs, so you can check the command, the method execution on the Neutron server logs.
So these decorators, registry.receives, it comes from which library?
At the top of the file are all the imports.
So that's the first import?
Yes, this one.
Okay.
These decorators are inside the Neutron lib library.
So that's already in the
So
Neutron code.
And then do I have to put this file inside the Neutron code,
Yes.
or can it be external in another?
This file is already inside the Neutron code.
Yes, but if
Not
I
in
want,
not in the Neutron code. It's in our case, it's inside the container of Neutron.
Yes.
but can I make another Python module and have it separated from Neutron? Or
But you need to ship. I don't know how you install OpenStack, but you need to ship it with your Neutron at the very end.
can it yes, but can it be in a separate module, or it doesn't have
Yes,
to
it
be?
can be a different
Yeah.
class, but it has to make all the import show. Yes.
Thank you.
Yes. In the configuration that we showed before, you have to use the path to this class that is implementing the router, and this path is from inside the Neutron code. But you could have another, for example, absolute path to the class that you are using as a plugin. This is the path that references the plugin that you are implementing. This is the name of the service provider that we are going to be using when we create a flavor that we're going to be.
This ipvrf.conf is from Neutron,
No.
and then I can put it in whatever module I want.
This Neutron ipvrf.conf, it's the configuration files for Neutron, yes. But the path of the plugin could be anywhere in the. Yes.
It follows the same syntax as the Neutron conf, but it's
So to this point, we can see that we have already implemented some logic on the Python class that we inspect, but the methods that are supposed to be the callbacks are not implemented yet, only have a log inside. So what we're going to be doing here is to create to call the API of Neutron to create a router, and we should see inside the Neutron server logs that this log already exists. So we can see this log on the Neutron server logs file. This is not going to be instantiating any virtual machine router because the logic is not created yet. But in the next activity, we're going to modify this method to create a BIOS router. And finally, we're going to be testing the correct function of this router by doing a ping from one VM on one network, one private network, to another VM in another private network. So the next activity of the workshop is to create, so inspect the other Neutron objects that are required to use our plugin. In this case, the other two objects are the flavor and the flavor profile. So you're going to get inside this container, because you have to execute these methods from your pod control. So if you do an OpenStack network flavor list, well, you first have to source the credentials file. So if you do an OpenStack network flavor list, you should see something like this. This means that a flavor, it's already created. What is a flavor? The flavor is the object that you attach to a router to tell Neutron that that router is going to be using the plugin that we created before. So as you can see, the name of the flavor has to match the configuration that you put inside the neutron.conf file. That name of the flavor comes from this configuration. So it has to match, so Neutron can tell from where it's going to be taking that logic of the plugin. So when we create a router, we are going to be using this flavor. We're going to tell the API of Neutron that the router must be created using this flavor. There is another object that we're going to be using called the flavor profile. The flavor profile is another object that contains the driver, in this case the class, that is going to be using for our plugin to implement that logic. And finally, we need a link between the flavor and the flavor profile. We link these two objects by using another command, but it's already linked. So if you do a show of this flavor, you should see that it's linked to the flavor profile. For example, we can do something like OpenStack network flavor show, and if we paste our ID, we should see that this flavor is already linked to the service provider profile. In this case, this profile that is linked also to the driver that is implementing our plugin. So these two objects are necessary for the router to respond in make the calls to the callback of the plugin. So now, if we want to create a router using this plugin, you have to indicate to the API of Neutron to use this flavor by using the flavor ID attribute on the OpenStack create router command. That is our next step in our first activity. So for doing that, we're also going to be checking the logs of Neutron to see that the plugin is executing the actual logic, that it's going to be logging the log of the execution of the method. So for doing that, you are going to open another terminal. And from that terminal, you're going to be doing a tail of the logs of the Neutron server. So for doing that, you have to SSH to the control node again. .1.68.0.50. From here, you should see the logs under the following path on the control node: var log cola neutron server.log. So all you have to do is to copy and paste this command inside the control server. So you hit enter, and now we are tailing the logs of Neutron to see the execution of the current logic of the plugin. So if we go to the other terminal, we're going to execute a router create using the current plugin that we have implemented. For doing that, you have to use the OpenStack router create command. And to indicate Neutron to use the flavor, you have to use the flavor ID argument. And the flavor ID that we're going to be using is the one that is listed after the OpenStack network flavor list command. You copy that ID and paste it in this command. That tells Neutron to create this router using this flavor. That means that this router is going to be making the callbacks to the code of the plugin that we see before inside the code of Neutron. And we give a name to this router. Please use the same name that I'm going to be using, because then we're going to be deleting the router and creating other for the other activities. So use the Paris router name for the router. Paris router. Okay. It's necessary to use the flavor ID, not the flavor profile ID. So if you use the flavor profile ID, the command is going to fail. Please check that you are using the flavor ID. So now you hit enter and switch to the other terminal to see the execution of the logs of the plugin. And in the other terminal, as I'm seeing before, that is the log that is contained inside the callback method. To this point, it's only logging this string, creating BIOS router, but it's not implementing any logic. That is what we're going to be doing later. We're going to be implementing the logic inside this method, but as it is now, we are verifying that a plugin is linked correctly to the router that we create. So it's all okay. We can continue creating and implementing the logic of the plugin. So what we're going to do now is to well, that was the first activity. Any doubts at this point? Okay, so we can continue to the second activity. In this case, we're going to be implementing the logic on both methods, the process router create, that is the callback for the router creation, and we're going to be changing also the process router delete, that is method for the delete router callback. So as I said before, there are some helper methods that are already implemented inside the class. For example, create Nova instance, delete Nova instance, attach port on instance. We're going to be using those methods to implement the logic of create the VM that is going to be working as a router, and for attaching ports on that VM to allow to route traffic between those two networks. We have also an execute command on instance. This was necessary because we have to do an DH client command inside the BIOS router VM to get an IP on the interfaces that we are attaching. But in the practice, we're not going to be using this command. We're going to be executing the command from inside the VM. So when we create the VM and attach the port, we're going to be using the VNC console of the VM to trigger an DH client command, so the interfaces on the router VM gets an IP, so we can router traffic between the two private networks that are already created in your environment. So What we are going to be doing now is modifying the class that is implementer of plugin to implement the real logic of this plugin, that is creating a VM and deleting a VM. In the next activity, we're going to be modifying the method that attach a port on the instance that is going to be allowing the BIOS virtual machine to route traffic between these networks and works as a router. That's what we want here. So what you should do now is go back to the first terminal that you open and do an Docker exec inside the Neutron server container. So once you're inside the container, you should do a vim command on the same file that we inspect before. That is a file of the plugin itself. So the methods that we're going to be modifying here are the process router create and process router delete. In the 18th slide, you have the code that we are going to be using to implement the logic on this method. So you can simply copy and paste the code inside the correct methods. Please make sure that the indentation in the file is okay, or we will have to make change to the container later. So first we're going to copy the process router create method and paste this logic inside this file. You could delete the method and simply paste the entire content after that. So make sure the indentation is okay. What this method is doing first is gathering some attributes from the payload of these methods. When we tell this method to be a callback, Neutron automatically pass some attributes to this method, so we can use it, for example, to get the router name, the router ID, which network is this router using, etc. So as you can see here, we are getting the router object that is under the payload states list. We're getting some context to use as a context for the session of Neutron to get, for example, some objects from the database. We're getting also the router name. We're logging some information. And finally, we are using the method that is already implemented. That it's the method for creating the BIOS virtual machine that we are going to be using as a router. In this case, this method only receives two arguments, a router name and the network ID. In this case, we're creating this BIOS router with an interface in the public network. This interface is only going to be using, for example, for management, or if you want get inside the VM. But in the practice, we're only going to be using the ports or interfaces that we are going to be attaching later. That is the interface on the private 1 network and private 2 network, that are the interfaces that are going to be allowing the router to route traffic between those two networks. So the next step is to modify the process router delete. Same as before, copy and paste the code. And what this method is doing, as we saw before, is gathering some attributes from the payload of this method to get the router name, so we can tell our delete Nova instance method which instance to delete. In this case, the instance is receiving the same name as the router, so we can tell Nova API to delete that instance, to delete the router. That is the logic of this plugin. So with those two methods, we are going to be creating a BIOS virtual machine that is going to be mocking the Neutron router, and we also are going to be deleting that virtual machine. So now what we have to do is to save those changes. For doing that, you have to write and exit the Beam session. You should exit the container also, and then because we are using the Python code, we can simply restart the container to apply the changes. So now you can do a docker restart Neutron server command. Now you should switch to the other terminal and wait for the log that is going to be telling us that the plugin is correctly initialized. You should see the log Paris L3 router initialized to make sure that the plugin and the changes were applied. So if you are getting this log, that means that you are doing good at this point. Everyone is okay? Yes? Yes? That means that now we can create or make a call to the Neutron API to create a router, and that it's going to be implementing or creating a Nova instance, in this case using the BIOS image, to create a router that is going to be mocking the original router of Neutron. So what I should do now is to make an OpenStack router create command, and we're going to be checking if this instance is created inside the Nova service. So now you should switch to the other terminal and create a router again. In this case, we're going to be calling this router by a different name, so make sure that you're using the Paris L3 router name. Paris L3 router. You hit enter, and you could switch to the other terminal to check the logs. You should see something like this, creating BIOS VM router, and you should see the other log that we created just before. That is created Nova instance. In this case, the name of that instance is Paris L3 router. So now you should be able to list the servers and check that the BIOS virtual machine router is created correctly. So if you do an OpenStack server list, you should see the BIOS virtual machine that is going to be working as a router. Make sure that you are using the --all argument to list the servers or on all projects, because the Paris L3 router is created on the service project. So you should have 3 VMs created. The Paris L3 router VM, that is our router that is implemented by the plugin. And you should see other 2 VMs called I1 and Y2 that are the VMs that we are going to be connecting to the router and checking connectivity between those 2 VMs that are on a different private networks. So as you can see, the I1 VM is on a private 1 network, and I2 is on the private 2 network. So the goal of this workshop is to being able to ping one VM from another using the Paris L3 router as a real router that is going to be routing the traffic between those 2 networks. Yes?
From which file are you controlling that the router has this flavor and this image?
Inside the code, you can see that the create Nova instance method, it's hard-coded with the image and the flavor. That is for the case of the workshop. But you can customize which attributes you are using. So to this point, we checked that the method that we implemented for creating the router, or in this case the instance, is working correctly. Now we're going to test the delete method. So if we execute a delete on our router, we should see that the BIOS virtual machine is also deleted. So if we do an OpenStack router delete command, router delete on the Paris L3 router, we should see that our VM is also deleted. So if we wait a few seconds and now we list the servers again, we can see that our Paris L3 router or VM is deleted. That means that our plugin to this point is working correctly, is implementing that logic that we want. It's creating a VM that is going to be working as a router, and it's also deleting this VM. In this case, we're using a BIOS virtual machine, so by default, the VM is going to be routing traffic. We don't need to do any configuration. If we attach an interface to the VM, it's going to be ready to traffic route from that interface to other interfaces that are listed or attached to the VM, to the BIOS virtual machine. So now we're going to proceed to the third activity. Everything, it's okay to this point? Yes? In this activity, we're going to be adding interfaces to our router so we can actually route traffic and use this VM to route traffic between 2 networks. Same as before, we're going to be modifying, in this case, the callback for respond to the attach an interface to a router. The callback that is implemented in the code is the process add router interface method. These interfaces that we are going to be attaching to the BIOS virtual machine need some configuration. As I said before, it's necessary for us to execute a DH client on the BIOS virtual machine to get an IP. The initial idea was to use the execute command on interface method, but we have some problems. So what we're going to do is to open a VNC console session on the BIOS virtual machine and do the DH client command by ourselves. Sorry? Yes, yes. Now we're going to be modifying the code of the process at router interface method. For doing that, in the 22 slide, you have the code of the method that we're going to be changing. As you can see, this method has a lot more of content than the other methods. In this case, because of the logic of Neutron, it's going to be necessary to create a mirror port of the original port that we are going to be attaching to the router. Because when we do a router add interface, what is going to be happening is that the router, the object router of Neutron, is going to be getting this interface attached. But we need another interface to the VM, so we can also have the VM connected to that network. So inside the code of this method, we are creating a mirror port that is going to be attached to the BIOS virtual machine. So the topology should be something like we have a router, we create we have the Neutron router, we have the interface that we're going to be attaching to that router, and behind what is happening is we're going to be creating a VM and a mirror port for the original port, so we could have the VM connected to the network of the original port. So in the practice, is only this method is only creating an extra port and attaching that port to the BIOS virtual machine, so we can get this virtual machine connected to the, in this case, private 1 and private 2 networks.
I see we're using hooks from Neutron.
Yes.
From Neutron, maybe you said earlier, and I could see the code. Is it documented somewhere in the Neutron documentation?
Not really. We have to search into the code and find some examples to replicate that logic. So it was a hard work, but there's no documentation that we follow for doing that. We have to check the code from inside. As usual, yes. So you copy and paste this code inside the Neutron server container. Yes. You should edit the same file as before. And the method is the process add router interface. In this case, I'm going to delete this method and paste the real content. Well, it's also necessary to import the Neutron client because we are creating a port. So we need to make a call to the Neutron API to create that mirror port. If you not do the import, the code is going to fail. So make sure that you copy this import at the top of the file.
Is there any reason why you are using the clients rather than the OpenStack SDK?
There's not really a particular reason. We start doing that and we follow using this client. So you could use another clients. It's important that you are replicating the creation of the objects that are necessary. You can use any Nova client or Neutron client to create the objects. You also could do an HTTP post to the API to create a instance or a port. It's not really. That's the real reason.
It's not important part or what we really want to know.
It's okay, it's okay.
We're human, it's okay. I don't have problem telling you that
Okay, now we should have ready our add router interface method. Let me check that indentation is okay. I think it is. So now I can exit the file, exit the container, and I have to restart the container. Restart Neutron server container. So we switch to the other terminal to check for the initiation of the plugin. And now our plugin should be ready to also attach an interface to the BIOS virtual machine that is functioning as a router. So what we're going to do now is to attach an interface to the BIOS virtual machine and to the router, and then we're going to be checking the network topology from the Horizon console so you can see what is the architecture that is going to be using for this plugin. So now we create our Paris L3 router again. You simply can search the command. Make sure that you're using the correct name, in this case Paris L3. We could switch to the other terminal to see that the BIOS virtual machine is created correctly. So it seems to be okay. Now I can, for example, list the servers, so I can check if the server is created correctly. No. And make sure to use the all argument because the BIOS virtual machine is created on the service project, and it's ready. As you can see, the router is active. To this point, only have the management interface on the public network. But now we're going to be creating an port on the private WAN network. That is the one of the networks that we're going to be testing for the connectivity. What you should do is to copy and paste the command to create a port on that network. We hit enter and the port should be created on the private WAN network. Then we are going to attach that port on the router and on the virtual machine. So I can copy and paste that command. And now our BIOS virtual machine should have a interface attached on the private WAN network. We're going to be checking that using the Horizon console. In this case, we're going to be using the admin and service project. And for allowing that, you should add the admin user to the service project so we can list the virtual machine that is created on that project. For doing that, go to the Identity tab under the Projects tab and click on Manage Users, Manage Members for the service project, and simply add the admin user to that project. Now you should be able to list the admin and service project from this drop-down menu. Stay on the admin project, go to the project tab, network topology. So here we can check the current network topology. In this case, you can see that in the private WAN network, we have one router created, that is the Neutron router, not the virtual machine. And it has attached one interface on the private one network. That is the interface that we just attached. There's also two VMs created that those are the VMs that we already created for you to check the connectivity between the private 2 and private 1 network. As you can see, those VMs are not connected for other router, are simply just connected directly to the private 2 and private 1 network. Now, if we switch to the service project, we're going to see the BIOS virtual machine that we created and how that virtual machine has a mirror port on the private 1 network. What we're seeing here is only the Neutron router, but what our plugin is doing is creating a virtual machine on another project. In this case, if we switch to the service network topology, we're seeing here that we have only one VM, that is the Paris L3 router VM, and it's connected to the private 1 network and also to the public interface, but we're not going to be using this interface. That is the management interface, for example. That means that our plugin to this point is working correctly. We attach an interface to our VM that is functioning as a router. So this concludes our third activity, and now we're going to be doing the final activity. This is the fun part when we are going to be testing connectivity between those two VMs. So as you can see here, by default, BIOS is going to be routing traffic without further configuration. So the only thing we have to do is to attach the port on the other network, and then we should be able to do a ping from one network to another. The traffic should be going to the BIOS virtual machine and route traffic from one test VM from another. So for doing that, we're going to create in our second port. In this case, this port is going to be created on the private network. And then we add our second port to the router. So now if we go to the network topology, we should see that our VM got two interfaces attached on each of these private networks, and it is. It has one interface on the private 2 and one interface on the private 1 network. So what we are going to be doing now is to execute a DH client command on the BIOS virtual machine, because by default the VM is not working. We not be able to get an IP after the boot. So you have to go to the service project. Under the project tab, compute instance, click on the Paris L3 router. Make sure to open another tab because we're going to be having several sessions for each of the VMs, so you don't lose this session. New tab. In this new tab, you're going to start a VNC console on this VM. Make sure to hit the click here to show only console. So other URLs going to be open. Unfortunately, this URL is not working, so you have to change it manually. For doing that, you have the column K. Just copy the IP import and switch the host on the on this URL, and it should be working. So copy that and change the host on this URL. You only have to change the host, the IP import. BIOS. Then you hit enter, and now you should be prompting the VNC console of the VM. The default login for that VM is BIOS for the login and BIOS for the password. Make sure to click the black screen so you can get access to the keyboard. BIOS, and now you should be inside the virtual machine. If you do an IP address command, you can see that the interfaces got no IP addressing on the private 1 and private 2. So to fix that, just run a sudo dh client command. After that, if you do an IP address command, you should see that both of our interfaces, ATH1 and ATH2, got an IP on both networks, the private 1 and private 2. So keep this session open, because we're going to be requiring these IPs to set the default route on the test net virtual machines. So that is the next step of our activity. In this case, we have to add a default route using the BIOS IP addresses on both of our test VM. That is the I1 and Y2 VMs that we have already created for you. So go back to the Horizon console. In this case, go to the admin project and open a new tab for the I2 and I1 VMs. You're going to repeat the same process as before. Click show here to only console, and then you have to switch the host of the URL. So it's really the same host, so you can simply paste the host. So that is the I2 virtual machine, and now you should open a VNC session for the one virtual machine. So I'm going to be changing the host again. And now I should have a session for the I2 and I2 VMs. Just click the black screen and then hit enter. You should be seeing the prompt of the login. The credentials for the zeros image is the user zeros, and the password is cops go. So log into the I1, sorry, zeros, go, cops, go, into the I1 and into the I2 VMs. And now our last step is to change the default route on the interface of each VM. If we check here, we have the ATH0 interface. In this case, this interface is the interface attached on the private 2 network. So what we have to do is to add a default route for our IP of the BIOS virtual machine on the private 2 network. First, we have to delete the current default route using the sudo IP route delete default. Just type this command on both VMs. Sudo IP route delete. And now you have to add the default route to the correct interface on the BIOS virtual machine. In this case, here I'm in the I1 virtual machine, so I have to add the IP on the private 1 network on the BIOS virtual machine. That is our 172.31 IP. So for doing that, I have to use the IP route add default command. Sudo IP route add default via, and because I'm in the I1 network, I should use the interface on the private 1 network on the BIOS virtual machine. That is 172.31.0.105 in my case. You should check your correct IP address. So now I can add a default route 172.31.0.105. And that should be on the ATH0 interface. And that's a typo. Now my I1 server is ready. Now I have to do the same on the second server. Sudo IP route add default via, and the IP address of the BIOS virtual machine on the private 2 network. That is, in my case, the ETH2 interface. That is 172.141.0.68. 172.141.0.68. And device ATH0. Well, and the last step is to test that our I1 virtual machine can ping the I2 virtual machine. That means that our BIOS virtual machine should be working as a router, routing traffic from the private 1 network to the private 2 network. So the IP of the I2 interface on the private 2 network is the 172.141.0.80. So I'm going to try a ping from I1 to I2. 172.141.0.80. And as you can see, I'm getting a response from the I2 network, I2 virtual machine. That means that our plugin is successfully implementing a functional router inside this OpenStack environment. This router is in the practice a virtual machine, in this case a BIOS virtual machine that by default is working as a router. So if you get to this point, congratulations, you build your first L3 plugin if you are not already building one or built one in the past. Please raise your hand if you are successfully completed this workshop. Guys, claps, claps.
One person does it because
Yeah,
we weren't that crazy. You may have like a lot of questions. Do you have? Are you still stuck with any of this? Have you surrendered? Do you have any questions to this point?
Yes. So I remember from Vancouver, it was as awesome as today. So thank you very much. Thank you very much for that. Like it's very useful. The only thing I missed from Vancouver was the code itself of that I used to. You taught me to write. So where can I find the code for the private router, Paris router code? Can I download it from somewhere? And same from Vancouver. Do you have the L2 plugins code available so I can go back and have a look?
We have the slides and we have the boilerplate of the code. I don't know if we have publicly available the full class, but I think it's still there because it was on Git. So
it'd be great if you could
yes,
publish those two somewhere.
You may contact us by email or by LinkedIn or something, and we can share it. And we may share this too. I haven't thought on that. I thought that with the slides would be enough, but you're right. You may want to. It's just a boilerplate after all, but you may want still want to have that. Please don't leave yet. I promise you. We want to take a picture before leaving, so please don't leave. And we have a surprise as well. Just to close, I wanted to say some things that basically all of this that we were doing, it's not something that you would typically do in production. It's very weird. It may happen, but it may be weird for itself to just mock this router with a virtual machine and do the same things that Neutron already does without a specific purpose. What we typically do and how we use this in production is that we implement the routers directly in the data center fabric. So we use the switches and the routers of the data center itself, and we configure those hardwares by OpenStack. And when that comes, you have to decouple the layer 2 and layer 3 functionalities, because here what we were intercepting was the part that, I create a router, I add a port, but we were not actually intercepting the layer 2 methods. For that, there is, of course, a layer 2 plugin as well, and that's the workshop that we did 2 years ago, so you can refer to a past version of myself to understand more about that, but it's basically the same thing. You will be intercepting layer 2 primitives instead of layer 3. And as I was saying, what we typically do in production is we have an SDN controller, and from OpenStack, we trigger the configuration of both layer 2 and layer 3 in our data center. So in particular, if we want a specific type of router for some reason, we just code a new layer 3 plugin and use that via our SDN controller. Yes. And this slide is just for selling you our product, which is our white SDN. And thank you very much. Please, if you have questions, yes, no, yeah, shoot.
Hello, thank you for the workshop. Small question, probably you answered it already, but let's say that I want to create the same router but with a different flavor. Should I do that in the flavor?
Yes, you may have like 80 different flavor profiles. Each is a different Python class, and you can make up any logic that you want.
And what are other options that are available in the flavor? Because I saw that you are injecting user data into the
yes.
VUS. Can
But
that be added via the flavor as well, or that means you have to create another class?
No, that's something that is related to the BIOS or the virtual machine that you're using. Again, if you're using BIOS, you may refer to BIOS configurations and do anything that BIOS want. But you may be using a proprietary virtual machine or any other thing, and you basically can do anything that you want. The BIOS developer that we have on the room was telling me that they actually have an API. So maybe you shouldn't be using just a script and inject the script. Maybe you can just do the configuration via API of the BIOS itself. So that could be just an interesting thing. But basically, just since it's code, you can just do the logic that you want. You may do a wrong logic or something like that.
Okay, thank you.
In our case, as I was saying, what we do is we call an SDN API. So the real logic of how to do the router configuration or whatever lies on the SDN. Okay. More questions?
Sorry. So also question. So here in the router create function, there is no return value. But normally, so iOS supports GraphQL. So normally, if we were to develop a proper plugin, we would like to send a command to enable GraphQL.
Yes.
So could we get credentials for the VM at that stage, so that process router create function would be able to?
Yes, there are another methods that could intercept of the router itself. You could do that before the creation or something like that. But basically, any command that you do in OpenStack router create, OpenStack route pod, even the floating IP or anything, those are some things that you may intercept in the code, and there you could, as you say, get the credentials or whatever.
All the details are in Neutron neighbor, right?
Yes.
Okay.
We have to check the code to find out which objects or which string in this case we can refer to intercept the open. There is a list of the router IP, from the IP, router interface, and so on.
You may also ask ChatGPT as well, as we did. More questions? Yeah, I like to hear that because we were really scared that nothing were going to work. So we want please to take a picture of the room ourselves, and we also were given surprise merch to give to you, but we only have 6 things. So we will be having to run a raffle, a random question. I don't know, but maybe no one wants it, so it's okay. We have from South America our own data center Lego, white cloud Lego, which is basically I hope this is not me. A rack of Lego that you can assemble. Instructions are in Spanish, but there are a lot of pictures, so I think it's... You don't need to read to do that. A kid can do that. And we have stack pods, airbag for headphone. Yeah, I'm from Argentina. I live in Chile. He's from Chile. He's from Argentina. We have like 3 and 3. It was what they gave us to ring. Yeah, you need to fight for it. Maybe if someone doesn't want it, they just can leave and it's okay. But I think the fairest would be just to do a random. But whatever gets it, it's okay. Maybe you can do the picture. Maybe we can do the picture first. Yes. So if someone, yeah, exactly. Yeah. Exactly what was I thinking. And thank you for coming. Because this part is